Hello, fifth grade science students. It's Mr. Miller again. Sorry about the bad camera, but I'm on a different computer. I'm in my office at school, and I don't have as nice a computer as I do at home. So you'll have to bear with my grainy picture. And I just wanted to talk to you a little bit today. Well, you've been watching a lot of videos, you've been taking a lot of notes in your science journal. And as you learn things about science, as you find things that are really interesting for you, I want to encourage you to continue on and do your own research and gain more information about the subjects we're talking about. And we've spent a lot of time talking about space and the solar system and Earth's place in the solar system. And we've talked about water being the key to life, and we have to investigate and try to find other planets that have water. And we spend millions upon millions of dollars every year looking for a planet that could sustain the human race, that we could go start a colony and actually be able to thrive and survive. Now, obviously, if we travel into outer space, we're going to run into some serious problems because as a human being, we have requirements that we have to be able to live. And so there's a lot of technical problems, and I've asked you to think about those, what kind of special equipment you would need to travel in outer space. And if you think about all of that, it really becomes overwhelming. But today I want to talk real briefly, why would we leave our planet? Our planet is the best planet in our solar system. We couldn't really thrive and survive on other planets like we can on Earth. Well, the simple truth is, if you believe all the politics about global warming and the thought that humans are destroying our planet, and that is such a huge theme when you think about science fiction movies where we have aliens coming in, landing on Earth, trying to kill us so that they could clean up the Earth, or they could take our water, or they're going to eat us as food. All of those things are kind of cool to watch, but understand it's all science fiction, which means it's not true. It really doesn't hold up to any scientific basis. But we do have to leave our planet. And why do we have to leave our planet? Well, we know that our sun is an old star. It's going to die at some point. Okay. And it's been a big ball of burning gas for over 5 billion years. And we know in a little over a billion years, just from mathematics, the amount of gas is going to burn down after 5 or 6 billion years, after 6 billion years. And what little gas is left is all going to explode at one time. And that's called a supernova. All stars eventually will supernova. Now, the good news for you and me, that's a billion years into the future. So how far is what do I mean when I say a billion? Most kids don't understand what that term million versus billion looks like. So let's talk money for a second. And I've got this little graphic to show you. Now, right here, we have a picture of a $100 bill. A $100 bill replaces a stack of $1 bills, and I would need 100 $1 bills to equal this single bill. Okay, so if I take $100 bills, that weighs about 3.5 ounces. Okay, so it doesn't weigh that much. I mean, we could just stick that in our pocket, we'd have $100. Or we could just take one of these and it replaces that. Now, what would happen as I stack $100 bills, if I put 100 $100 bills in a stack, now I have $1,000. So what does that look like if instead of a $100 bill, I stacked single dollars or dollar bills? And this is what it would look like. Okay, here is $10,000 in the hundreds. If it was all in dollar bills, this is how big of a pile of cash I'd have to carry around. And that I couldn't fit in my pocket. I would probably need a suitcase to carry the $100 or the $10,000. and now I could go spend that money. But what is that going to weigh? Well, that's going to weigh about 2.2 pounds. And that's a lot heavier than just this single stack here, which weighs about 3.5 ounces. Now, what happens if I want to talk about $1 million? Okay, and it's all in ones. Now this pile gets magnified, and now I need a pallet. And I have a pallet of ones that is $1 million, and $1 million of ones weighs about 11 tons. So I couldn't carry that around. I couldn't steal it. I would need a forklift and a big truck to carry it. So all these shows people are stealing millions of dollars. Even if I replace these ones with 20s, I'm still talking about hundreds and hundreds of pounds of money. Okay. And now this is $1 million. What would $1 billion look like? Well, $1 billion turns out that I would have 1, 2, 3, 4, 5. So now I have 10 pallets, and 10 pallets would be about 22,000 pounds or 1,100 tons. And now I'm talking about I need a semi to be able to carry that. I mean, I couldn't put it in my trunk and in my car, it would smash down. And then if I look, here is that, what do I say? This is the million. If I go to $1 billion, here's the million, it would be loaded into our billion. Then this is $1 billion, okay? And this would be $1 trillion. So orders of magnitude, okay? So think about that when we talk about million, billion, trillion, there's huge differences between them, all right? So the other thing I wanted to tell you is if we were going to leave our planet, what would that entail? Well, we talk about distances in space as astronomical units. We use something, and you're going to be introduced in the video as distances being in light years. Now, what's a light year? Well, a light year is the distance that light travels over a 1-year period of time. So how far is a light year? Well, if I think about the speed of light, and light is the fastest thing we've ever discovered. Light travels at about 670 million miles per hour. Okay, so think of an hour. And we have 24 hours in a day. We have 365 days in a year times 670 million. Now we're talking trillions upon trillions upon trillions of miles in 1 year. Now, if we were going to leave our planet and we had to travel somewhere, let's say it's 1 light year away, well, how long would that take? Well, one big problem is if we accelerate a human being from 0 up to light speed, which we can't do, it's impossible. We haven't developed any technology. We only have thought about it and put it in science fiction movies. But the fastest thing we've ever built was the Apollo capsule that took us to the moon. And remember, that came before the space shuttle, and that was all in the 60s, 70s, and 80s. So it's old technology. And then we had the space shuttle coming in the 80s, 90s, and now we don't even use those. We're using other kinds of things. But the Apollo was the fastest, and the Apollo, where is it? Oh, could travel almost 25,000 miles per hour. Now think how fast 25,000 miles per hour is. That's very fast. But that's still not even close at 25,000 to 670 million miles per hour. So that means even if we took the fastest thing we had and we were trying to leave our galaxy, it would take us about 37,000 years to travel 1 light year. And that's at the fastest technology we have. So obviously, if it takes that long and we have to leave our solar system and be so far away before the sun supernovas, then that means probably in the next thousands of years, we better have a way to travel in outer space. If all the predictions, and as more and more people are on the planet, we run, more out of resources. And they would like to have half the population, which would relieve a lot of the pressure on the resources here, and somebody else go to another planet and start a colony, start a race, and have more humans. The problem you're going to find out as you watch these videos and you take your notes in your science journal and answer your questions, you're going to find out that space travel is not very easy. The distances are incredible. Most of the people on this journey are going to be dying along the way. And it's going to be great by 1,000 generations before they ever get to these new worlds. And we'll never know. So think about that. Watch the video, and hopefully you have fun watching them. All right, talk to you later.